All right, guys. Hello. Today's a good day. I feel with good energy to actually tackle this room. The name of this room is Shell's Overview from TryHackMe. I'm gonna be joining the room right now, and let's get to it. I've already connected to the VPN. I'm gonna go like the room, and let's start. Room introduction. Shells in cybersecurity are widely used by attackers to remotely control systems, making them an important part of the attack chain. In this room, we'll explore different shells used in offensive security, the differences between them, and their use cases. This knowledge can help enhance penetration testing and exploitation skills, and also help us understand how to detect when a remote shell is being used by an attacker within an organization. Learning objectives. In this room, we'll cover the following learning objectives: understand shells in offensive security, set up and use reverse and bind shells, deploy web shells. There are some prerequisites for this room: basic understanding of networking, fundamental knowledge of web application security, basic command line proficiency, familiarity with scripting languages like Bash, Python, or PHP, or Ruby, which is my favorite. Caveats. The use of Metasploit or other framework that generate or interact with shells has been intentionally left behind from this room. This is to focus on understanding how shells work without the use or assistance of a tool to either set up or generate a shell. Also for this room, we'll use Linux OS for all the examples. Okay, let's go ahead and start the machine. Also, a side note, guys, I will be installing Ruby on this Kali machine. While I tackle this, there's just something that's been uh, it's gonna be loading on the site. So yeah, that's but as far as the room goes, I'm gonna be going through the room because Ruby is actually the programming language that I use to basically create some scripting for some tasks. So that's what I will be doing, installing Ruby. But yeah, let's keep going. Start the machine. All right. Start lab by clicking the start machine button. It will take around 2 minutes to load properly. And then the VM will be accessible on the right side of the split screen in case the VM is not visible. Use the blue. Yeah, okay. Since we're practicing with shells that have remote access, we can use the attack box by clicking on the attack box. Okay. There's no SSH credentials, I guess. This attack box is the one that I have to use. So what is a shell, right? A shell is a software that allows a user to interact with an OS. It can be a graphical interface, but it is usually a command line interface, and this will depend on the operating system running on the target system. In cybersecurity, it commonly refers to a specific shell session an attacker uses when accessing a compromised system, allowing them to run commands and execute software. This will allow attackers to execute several activities, some of which are described below. Remote system control allows the attacker to execute commands or software remotely in the target system. Privilege escalation. If initial access to a shell is limited or restricted, attackers can explore ways to escalate privileges to more elevated or administrative access. Data exfiltration. Once attackers have access to execute commands through an obtained shell, they can explore the system to read and copy sensitive data from it. Okay. And then persistence and maintenance access. Once shell access is obtained, attackers can create access to users and credentials or copy backdoor software to maintain access to the target system for later usage. And then post-exploitation activities, right? After access to a shell is granted, attackers can perform a wide range of post-exploitation activities, such as deploying malware, creating hidden accounts, and deleting information. Access other systems on the network. Depending on the attacker's intentions, the obtained shell can be just an initial access point, which we also call the foothold, right? The goal can be to hop through the network to a different target using the obtained shell as a pivot to different points in the compromised system network. This is also known as pivoting. As all of the shells we will describe in the next task can help to achieve different limitations of the attacks described above. So what is the command line interface that allows users to interact with an operating system? That would be a shell. Okay, what process involves using a compromised system as a launching pad to attack other machines in the network? What process? Using a compromised system? That would be, okay, as a launching pad to attack other machines in the network. Mm, obtained? What process? What process? Involves using a compromised system. Initial? Pivoting. Damn. Okay, what is a common activity attackers perform after obtaining shell access to escalate their privileges? Well, just escalate their privileges. Attackers usually do privilege escalation. Okay, reverse shell. Reverse shell. Okay, reverse shell, sometimes referred to as connect back shell, is one of the most popular techniques for gaining access to a system in cyber attacks. The connections initiate from the target system to the attacker's machine, which can help avoid detection from network firewalls and other security appliances. How reverse shells work. Set up a NetGAT listener. Okay, let's now understand how reverse shell works in a practical scenario using the tool NetGAT. This utility supports multiple OSs and allows reading and writing through a network. As mentioned above, a reverse shell will connect back to the attacker's machine. This machine will be waiting for a connection, so let's use netcat to listen to a connection using the following command. nc nc minus lb and bnp and then 443. So the command above uses the -L option to indicate netcat to listen or wait for a connection. The -V option enables verbose mode. The -N option prevents the connection from using DNS for lookup, so it will not resolve any hostname. It will use an IP address. Finally, the -P flag indicates a port that will be used to wait for the connection, right? And we've specified port 443. Okay, any port can be used to wait for a connection, but attackers and pen testers tend to use known ports used by other applications like 43, 80, 8080, 443, 139, or 445. This is to blend the reverse shell with legitimate traffic and avoid detection by security appliances. Gaining reverse shell access. Once we have a listener set, the attacker should execute what is known as a reverse shell payload. This payload usually abuses the vulnerability on unauthorized access granted by the attacker and executes a command that will expose the shell through the network. There's a variety of payloads that will depend on the tools and OS of the compromised system. We can explore some of them here. Okay, let's take a look. Yeah, I've used this before. Okay, so let's keep going. As an example, let's analyze an example payload named a pipe reverse shell, right? Where's that? As shown below. Okay, so remove -F. TMP, this removes this particular file. Schema removes any existing named pipe file located at TMPF. This ensures that the script can create a new named pipe without conflicts. And then make FIFO. This command creates a named pipe as FIFO, first in, first out. At TMPF, named pipes allow for two-way communication between processes. In this context, it acts as a conduit for input and output. Cat TMPF, this command reads data from the named pipe. It waits for input that can be sent through the pipe. And then bash -I2 bigger than symbol 1. The output cuts its pipe to a shell instance. Yeah, which allows the attacker to execute commands interactively. The 2 bigger than symbol 1 redirects standard error to standard output, ensuring that error messages are sent back to the attacker. Okay. And then the NC, attacker IP, attacker port, and then TMPF. This part pipes the shell's output through NC, which is netcat, to the attacker's IP address on the attacker's port. And then TMPF, this final part sends the output of the commands back into the named pipe, allowing for bidirectional communication. The payload above can expose the shell bash through the network to the desired listener. Okay, so the attacker receives the shell. Once the above payload is executed, the attacker will receive a reverse shell, as shown below, allowing them to execute commands as if they were logging into a regular terminal terminal in the OS. Attacker terminal output. So when you receive that, yeah, you're basically just able to execute commands on this target machine. The output above shows the connection coming from the IP 10.10.13.37, which is the IP address of the compromised target. What type of shell allows an attacker to execute commands remotely after the target connects back? That would be a reverse shell. And then what tool is commonly used to set up a listener for reverse shell? NetGap. And then bind shell. Okay, as the name indicates, a bind shell will bind a port on the compromised system and listen for a connection. When this connection occurs, it exposes the shell session so the attacker can execute commands remotely. This method can be used when the compromised target does not allow outgoing connections, but it tends to be less popular since it needs to remain active and listen for connections, which can lead to detection, right? How bind shell works. Setting up the bind shell on the target. So let's create a bind shell. In this case, the attacker can use a command like the one below on the target machine. Remove -R. If you remove this, make 5 This is pretty similar to the previous command, except for the part where you just specify 08080. Okay. Starts netcat in listen mode on all interfaces on port 8080. The shell will be exposed to the attacker once they connect to this port. Okay. So you're basically inviting the hacker to connect this port so that they can have access to this. And then this final part sends the command's output back into the main type, allowing for bidirectional communication. The command above will listen for incoming connections and expose a bash shell. We need to know that ports below 1024 will require netcat to be executed with elevated privileges. In this case, using port 8080 will avoid this. Terminal target machine. Okay. Once the command is executed, it will wait for an incoming connection as shown above. Attacker connects to the bind shell. Now that the target machine is waiting for incoming connection, we can use netcat again with the following command to connect. Netcat -NV and then the target IP and the 8080 port, which is the one that the target machine is waiting for us, right? They're listening on that particular port. And C disables netcat, yeah, establishes the connection to the target, -N disables DNS resolution, allowing netcat to operate faster and avoid unnecessary lookups. Verbose mode, okay, target IP, the IP, and then the port, right? So attacker, this, okay, what type of shell opens a specific port on the target for incoming connections from the attacker? That would be the bind shell. And then listening below which port number requires root access or privilege. Listening below which port number requires 1224, 1024, right? And then shell listeners, okay. What did you make me start this machine for? I guess it's until we get to the practical task. Okay. Okay, it's still installing. As we learned in previous tasks, a reverse shell will connect from the compromised target to the attacker's machine. A utility like netcat will handle the connection and allow the attacker to interact with the exposed shell. But netcat is not the only utility that will allow us to do that, right? Let's explore some tools that can be used as listeners to interact with an incoming shell. I've never used this tool personally. It is a small utility that uses the GNU readline library to provide editing, keyboard, and history. Okay, so this wraps NC with RL wrap, allowing the use of features like arrow keys and history for better interaction. NCAT. NCAT is an improved version of NetCat distributed by the Nmat project. It provides extra features like encryption, SSL. Okay. Usage example, listening for reverse shells with SSL. Cat --SSL, and then this one. Okay. The SSL option enables SSL encryption for the listener. And then SOCAT, it is a utility that allows you to create a socket connection between two data sources. In this case, two different hosts. Default usage example. Okay. It is a utility, okay, creates two socket connections between two data sources. This should be listened for 3 and start out. Okay, the command above uses -D option to enable verbose output. Using it again, -d will increase the verbosity of the commands. The TCP listen 443 option creates a TCP listener on port 443, establishing a server socket for incoming connections. Finally, the STD out option directs any incoming data to the terminal. Which flexible networking tool allows you to create a socket connection between two data sources? That would be the socket. Then which command line utility provides readline style editing and command history for programs that lack it, enhancing the interaction with the shell listener? That would be the one that allows us. Uh, Netcat. What was it? Ncat. What? Which command line utility provides readline style editing? Oh, I think it's this one. My bad. What is improved by Ncat? Okay, we got it correct. Then shell payloads. Uh-huh. Okay, shell payloads. A shell payload can be a command or a script that exposes the shell to an incoming connection in the case of a bind shell, or a send connection in the case of a reverse shell. Okay. Let's explore some of these payloads that can be used in the Linux OS to expose the shell through the most popular reverse shell. Bash. Normal bash reverse shell. Okay. So then to specify this, you specify the attacker IP address. For this reverse shell initiates an interactive bash shell that redirects input and output through a TCP connection to the attacker's IP. On port 443, this operator combines both standard output and standard error. Okay, bash readline reverse shell. Okay, this reverse shell creates a new file descriptor, 5 in this case, and connects to a TCP socket. It will read and execute commands from the socket, sending the output back to the same socket. Bash with file decryptor 196 reverse shell. Uses file decryptor 196 to establish a TCP connection. It allows the shell to read commands from the network and send output back to the same connection. Okay. Bash with file decryptor 5 reverse shell. This looks similar to the one before. Where's different now? Okay, this is bash with file decryptor, right? Similar to the first example, this command opens a shell bash -i, but it uses a file decryptor 5 for input and output, enabling an interactive session with over the TCP connection. Then PHP reverse shell using the exec function. This reverse shell creates a socket connection to the attacker's IP on port 443, and uses the exec function to execute a shell, redirecting extender input and output. PHP reverse shell using the shell exec function. Okay, this is the function similar to the previous command, but uses the shell exec. Okay, reverse shell using the system function here, which executes the command and outputs the result to the browser. PHP reverse shell using the pass-through function. This is the function. Then you pass in some parameters. Executes a command and sends raw output back to the browser. This is useful when working with binary data. Okay, PHP reverse shell. Using the popen function, which is this one, to open a process file pointer, allowing the shell to be executed. Okay, and then Python reverse shell by exporting environment variables, our host target. This is the one that I've used before. I remember it. Export and specify the port -c, and then you specify some Python code. This reverse shell sets the remote host port as environment variables, creates a socket connection, and duplicates the socket file decryptor for standard input and output. Python reverse shell using the subprocess module. This reverse shell uses the subprocess module to spawn a shell and set up a similar environment as the Python reverse shell by exporting the environment variables command. Okay, short Python reverse shell. Okay, this reverse shell creates a socket S, connects to the attacker, and redirects extender input, output, and error to the socket using os.dub2. Okay, others telnet. We have telnet. Okay, this reverse shell creates a named pipe using MKFIFO and connects to the attacker via telnet on IP, the attacker IP, and port 443. AWK. This reverse shell uses AWK's built-in TCP capabilities to connect to attacker IP, same port. It reads commands from the attacker and executes them. Then it sends the results back over the same TCP connection. And then BCBox. BCBox reverse shell uses NCAT to connect to the attacker at this particular IP 443. Once connected, it executes bin sh, exposing the command line to the attacker. Okay, so which Python module is commonly used for managing shell commands and establishing reverse shell connections in security assessment? Well, we just read about it, right? Subprocess. Then what shell payload method is a common scripting language? I'm sorry, what shell payload method in a common scripting language uses the exec, shell exec, system pass-through, and open functions to execute commands remotely through a TCP connection? What shell payload? Method in a common scripting language uses exec. I'm not sure here. Only three letters. Oh, okay. What shell payload method is a common scripting language? So I would guess it's PHP. It uses exec, shell exec, system, pass through, and open. Yeah, it's PHP. And then which scripting language can use a reverse shell by exporting environment variables and creating a socket connection? That would be Python. Then web shell. Okay, web shell. Let's get it. Web shell is a script written in a language supported by a compromised web server that executes commands through the web server itself. A web shell is usually a file containing the code that executes commands and handles files. It can be hidden within a compromised web application or service, making it difficult to detect and very popular among hackers. Web shells can be written in several languages supported by web servers like PHP, ASP, JSP, and even simple CGI scripts. Example PHP web shell. Okay, let's look at an example PHP web shell to understand how this process works. The above shell can be saved into a file with a PHP extension like shell PHP and then uploaded into the web server by the attacker by exploiting vulnerabilities such as unrestricted file upload, file inclusion, command injection, among others, or by gaining unauthorized access to it. Although after the web shell is deployed in the server, it can be accessed through the URL where the web shell is hosted. In this example, this particular shell. Okay, as we observed from the code in shell PHP, we need to provide a get method and the value of the variable cmd, which should contain a command the attacker wants to execute. For example, if we want to execute the command who am I, the request for the URL should be PHP then cmd. So yeah, okay. The above command will execute the who am I and display the result in the web server. Existing web shells available online. The power of supported languages by the web servers can result in web shells with lots of functionality and avoid detection at the same time. Let's explore some of the most popular web shells that can be found online. Pony Shell, a minimalistic single file PHP web shell that allows remote command connection. I'm sorry, remote command execution. And then B374K shell, a more feature-rich PHP web shell with file management and command execution among other functionalities. Then C99 shell, a well-known and robust PHP web shell with extensive functionality. You can find more web shells here. What vulnerability type allows attackers to upload a malicious script by failing to restrict file types? What vulnerability type? Uh, would it be unrestricted file upload? Yeah, what is a malicious script uploaded to a vulnerable web application to gain unauthorized access? Is that a web shell? Yeah, it is. Okay, practical task. Now that we have learned about the different types of reverse shells, let's just show this split screen. Let's test our knowledge with a practical exercise, and let's get the flag in the format THM from the vulnerable web server. Click on the Start Machine button to start the challenge. After that, it will be accessible to the following URLs. So hosts the landing page. Okay, let's check out that landing page. I'm not able to see what up. Now we're able to get commands. So what is going on? I don't get it. Why can't I access? What if I access it from my attack box? Still unable to connect. I don't get it. Why? Somehow it's not loading my two. Why might that be? Could it be a problem with the box? With the machine that we've just started? It is receiving. It is receiving pain stuff. So connection refused. And why? I'm not connected. Could it be because of the upgrade that I'm running? I don't think so. Okay. Nothing when you see. Receive that. It's in 5 pins. Sure packet logs. So then why am I not able to access them? If I go here. Method not allowed. Invalid for this resource. What is the content of the flag saved in the directory? I mean, I want to do this, but it's not allowing me even to check out the landing page. Like, what's wrong? It's weird. what should I do? I terminate this machine. Terminate the target machine or use your machine connected to the VPN. I mean, I'm using my machine connected to the VPN. Uh, oh, okay. I think this is the one that I had to start. Is that right? Maybe not. No, it's not. Okay, but let's see if restarting the machine helps a bit, right? Because if this is hosting the landing page, I should be able to access it and check out how the landing page looks. Let's wait a bit. Okay. Come on, tell me it's working now, please. This one hosts the application. I don't get it. Oh, okay, finally. Okay. Okay, you just had to restart the machine. So let's get it. Okay, we have all of them open here. Okay, so this is the basic landing page, correct? Okay, so you can access the, okay, using a reverse Turbine shell. Okay, so what I want to do is, I guess if I'm gonna be using a reverse shell, which is the case for this one, I want to be listening on this particular port, and then I'm gonna be using that, then as an example, name to pipe, attacker IP, attacker port, gain a reverse shell. Okay, so let's just use this one. This is the landing page, right? This is the one that I want to use. Input a file, try hello text. What? Oh, sorry. I had to put in the attacker IP, which in this case is 10.6.69. I'm sorry, 10.6.61 124. 10.6.61 124. And then the attacker port would be 443. And then what if we send it? Do we get a response? Yes. Okay. So what are you asking me here? Exploit document injection vulnerability. Okay. To get a shell. What is the content of flag saved in the root directory? But which flag? Can't see the into root. Okay. Maybe. Oh, okay. I found it. It was the flag. So cat flag.txt. It gets me It gets me this, and then we can submit that. And then the next one, using a web shell, okay, which is this one. Exploit the unrestricted file upload vulnerability and get a shell. So using a web shell, upload, browse, upload your CV. Okay. A web shell, exploit the unrestricted file upload and get a shell. What is the content of the flag saved in the directory? Okay. Using a web shell, but okay, so I guess let's exit this. Here, like we want to use a web shell task. Then, so we have to be here. We're looking for a data scientist to help in our daily operations. So what I want to upload here is, there was an error uploading your file. Yeah, sure. So shell listeners, shell overview. Okay, using a web shell, exploit the unrestricted file upload vulnerability. Unrestricted file upload. So there's no restriction on what file I can upload, right? So I guess, how do I go about basically providing it with a file that will give me a reverse shell? I want a reverse shell, so I'm gonna be listening here, and then I guess I want to create a file. So where am I? Make there shells overview, and then I want to create a file here that's gonna be uploaded. Shell payloads. Is it? Is it gonna be uploaded? Am I thinking? Is my thinking correct? What's the hint? Use the payloads learned in task 7 to create a file called shell php. Yeah, right. The above shell can be saved into a file with PHP and then uploaded into a web server by the attacker by exploiting vulnerabilities such as this one. So example of web shell. Okay, so let's use that, right? So I'm gonna be vim shell.php. What do you mean? Okay, so what if I just upload that file, right? I have this content inside, and then let's browse. I'm in Cali, CTF, TryHackMe, shells, oh, shells overview, shell, and then upload. The shell PHP has been uploaded. So then I should be able to access whatever IP here, and then instead of index, shell.php, right? And then I should be able to execute commands with this, like cmd. Who am I? Not found. Is that correct? Not found. Hasn't it been uploaded? Where does it get stored if I upload it? Would it be here? I don't think so. shell.php. Oh, okay. Looks like it found something. What if I just CMD? Who am I? From here illustration. Nope. What am I doing wrong? Okay, so the above shell can be used to can be saved into a file with the PHP extension, then uploaded into the web server, which is what we have just done. And then after the web shell is deployed in the server, it can be accessed through the URL where the web shell is hosted. In this example, oh, it would be under the uploads, right? So it would be here, and then uploads forbidden. If I go here, not found. 8082 uploads. Okay, but if I go to shell PHP, okay, it looks like it's giving me something. And then if I CMD, who am I? Oh, okay. Now we got somewhere. We have a reverse shell working. I'm sorry, a web shell working, right? Using a web shell, exploit the unrestricted file upload vulnerability, which we have already done, and get a shell. So I got a shell, like, yeah, a web shell, right? What is the content of the flag saved in the directory? So what I want to execute is the command is gonna be cd. But wait, how do I go about typing long commands? Let's check it out. Who am I? Display the result in the web browser. Yeah, I don't wanna use cd and then root. No, let's first ls and then root. Okay, so what I want to do is cat and in here black.txt. Yeah, we got it. We got it. This is how we do it. Okay, that's sweet. Okay, the conclusion. In this room, we'll learn about reverse shells, bind shells, and web shells, right? How they are critical for attackers, penetration testers, and defenders, and how to identify them. Reverse shells establish a connection from a compromised machine back to an attacker's system. Bind shells, on the other hand, listen for incoming connections on a compromised machine, right? And web shells offer attackers a unique avenue for exploiting vulnerabilities in web applications, right? Understanding shells is critical for security professionals to either perform penetration testing exercises or to identify and defend systems, right? I have successfully completed the room, and now I understand how reverse shell, bind shells, and web shells work. Sweet. All right, this was a good review, guys, because I've done this before, but as I stated, I've been away from TryHackMe for a while, so I've not been doing CTFs and stuff, so I got kind of rusty, right? But I'm getting used to this again. So yeah, that's good. I feel good. So yeah, that's it for today, guys. Thanks for watching the video.